Hi, and welcome back to Basic Logic, Open Introduction. I'm Dr. Nick McGinnis. We're looking at Chapter 8 of For All X, the Lorain County remix, where a natural deduction system or natural proof system for sentential logic is elaborated. In this video, the third part over Chapter 8, we're going to be doing some more advanced derivations using the basic introduction and elimination rules that I've already introduced. So, the first thing we should talk about very briefly before we start doing lots of examples is that it's okay to repeat yourself. It's okay to repeat yourself. It's okay. Got old. No, but seriously. Earlier I said that one of the interesting kind of paradoxes in the material conditional is that for any true sentence P, then if Q, then P is true. Sure, that's weird. But can I prove it in my conditionals, in my derivation system? The answer is absolutely yes. Suppose I have P as a premise. Then I can assume Q, because I want to build the conditional if Q, then P. Can I derive P from Q? Well, I don't need to derive from it. I can just reiterate it because I already know that P is true. So the R rule just allows you to repeat yourself. Anything you already know to be true, especially if it's like to the left but not to the right of you in an old closed and nested subproof, you can just repeat. So I know I have P. I have that on the main line. So I know that it's definitely true because it's one of the foundational premises of my argument. So I have P. I assume Q. If Q is true, then P is true. So if Q, then P is a totally valid discharge. I can absolutely go back to the main line and say, hey, look, turns out if I assume Q, I can get P. So again, the truth table, if P, therefore, if Q, then P is absolutely a tautology. So just a way to illustrate the fact that anything you already know to be true, you can repeat and then reuse. This will be important in conditional proofs, especially like if you're doing negation introduction, negation elimination, and you need to show that there's a contradiction. So if you derive something and you already have its opposite somewhere else, you can reiterate it, show the contradiction, and then derive the opposite. So let's do some of these exercises. Let's do, I'm going to not do all of them, but what you should do is kind of pause the video here, or after I've done a couple of them, and then work on them yourself. So I'm going to do maybe the first couple, and I'm going to write them down over here, then I'm going to enlarge the video. Again, I apologize in advance for how terrible my handwriting is. So premise 1 is A. Premise 2 is if A, then B. And I'm trying to derive, my target sentence here is A and B together. That's actually pretty easy. You're going to do that really quick. Maybe I'll choose a harder one after. So this is my premise. This is my premise. Let's make the video larger. This is my target sentence. I want to derive if A, then B. This will show that A and B is entailed by the premises. In other words, that the argument where this is the premise, this is the conclusion, is a valid argument. So how am I going to do that? Well, let's look at that target sentence. The main logical operator is a conjunction, so I'm probably going to want to use conjunction introduction. How do I get conjunction introduction? Well, I need both conjuncts. I already have A. That's good news. If I have A and if A then B, that looks a lot like I can use conditional elimination. So I can get B from lines 1 and 2, conditional elimination. Here I'm just commenting my code. Somebody says, wait, how did you get B from? Well, look at lines 1 and 2, conditional elimination. I don't have to do this step, but I like to for cleanliness, right? I'm just repeating line 1. And then I can conjoin them by going, oh yeah, A and B, because I have each of them on the kind of main scope line, on the main line here, and that's conjunction introduction. That's actually a very, very easy example. Let's choose a slightly harder one. Now, if I was more patient and had better video editing skills, I'd probably just pause the video, erase the board, and start over. I feel like I'm going to have like 8 hours of video when this is done, and stopping and getting rid of every and ah is going to be this really mind-numbing task. All right, which one should I do? How about number 3? That one looks more complicated. And then I'll leave the rest to you, the viewer. Maybe I'll do another one. We'll see. So premise, okay, there's only one premise. That's good. I like one premise arguments. Our premise is if A is true, then not B and not C. Is that right? So if A is true, then not B and not C. Now my target sentence is itself a conditional. That conditional is if A, so what I want to derive is if A, then not C and not B. That's just the opposite in there, isn't it? If A, then parenthesis not C and not B. So this is a pretty easy thing to build. Can we see here? Sorry about the glare. So our target sentence is a conditional. That's the main logical operator. So probably what I'm going to want to do is use conditional introduction. What does conditional introduction look like? Well, I have to introduce a vertical line for my assumption here. So everything on this side of the line is going to be a function of what I'm hypothetically assuming here. Suppose A is true. What would follow from that? Supposing A is true. So here's my sub-assumption. I'm going to call that S sub-assumption here. Why am I trying to do that? I'm trying to do a conditional introduction. That's what I'm trying to run here. I'm not doing negation elimination or something like that, or negation introduction. So if A is true, what happens? Well, if A, then this. So I have the consequent, right? If A is true, then not B and not C. How do I know that? From 2-1 conditional elimination. That's good. I'm making progress here. In fact, I'm going to wrap things up pretty fast because I know I have not B. I know I have not C. How do I know? I have 3 conjunction elimination, 3 conjunction elimination. Then line 6 down here, what am I going to do? I'm going to join these back the way I want them. I have not C and not B. That's from lines 4, 5. I'm just joining them back together. That's conjunction introduction. So I know that if A is true, then not C and not B is true. That's not a super interesting argument, of course. It just means that I can like flip around the and here in the antecedent, but whatever. Main line, I'm going to go all the way down here. Can you see me? If A is true, then not C and not B. How do I know that? Lines 2 through 6, conditional introduction. Pretty easy. I spent so much time on my computer, my handwriting has turned into childlike scrawls. All right, should we do another one? All right, one more. How about the last one, number 7? Fun part, where I erase things. Excuse me. All right, so we have 2 premises. One long conditional premise and a shorter atomic sentence. That's useful. We'll start all the way up here. And boy, is this complicated. Not what? Not I and M. Or if not I and M, then what? If not I and M, then L, then not N. L and not N. So that's a very long first premise. Second premise is more simple. It's simply N. And what I'm going to want to derive is I and M. So, oh boy, this one's going to be fun. So my target derivation is I and M. So now, okay. So now my target sentence where is it? Up here is a conjunction, I and M. So I know that I needs to be true and M needs to be true. How do I get it out of there? Well, gosh, this could actually be pretty complicated because I and M seem completely stuck inside this conditional here. And all I have to work on is N. So how am I going to break out I and M? Now I know the argument is valid, so I just need to figure out the correct strategy for getting it out. Now, we know that, let's think about what it's expressing for a sec. It's saying that if not this, than that. Now, I'm probably going to need to make an assumption. What kind of assumption am I going to need to make? Well, maybe, all right. Oh, did I just wander off frame here? All right. Maybe what I need to do, since I know it's a conjunction, maybe I need to make a couple of assumptions, such as the opposite of my target sentence. Now, when I make a negated introduction or negated elimination subassumption, that doesn't have to be an atomic sentence. That could be a more complex sentence. So, suppose I introduce the opposite of my target sentence. If I'm at a loss how to proceed, if you're like not sure what to do, worst case scenario, assume the opposite of your target sentence, of what you're trying to derive. And if you do that, maybe you'll find that contradiction. So let's try that strategy. So what I'm going to do is assume the opposite. I'm going to say, this is what I want. I'm going to say, suppose my target sentence is false. Now, it turns out this is actually a pretty useful assumption to make for negation elimination. If I derive a contradiction, I'll be able to discharge this. Now, this is actually a pretty useful assumption to make because it turns out that if I assume the opposite of my target sentence, I get the antecedent of this conditional. I'll edit that in post. That's good. But having the antecedent of a conditional doesn't yet quite give me a contradiction. Well, that's okay. Sometimes even if I don't see the contradiction right away, what I'm going to want to try and do is make some moves and hopefully be able to make some progress. So if I have the antecedent of this conditional, what else do I have? Well, I have its consequent. Now remember, when I do something like if P then QP, therefore Q, I'm not necessarily just doing it to atomic sentences. I'm doing it to any complex sentences that have that basic form. And here we have that basic form. If P, then Q. P is this whole thing here. Q is that whole thing there. Now I have this P. Therefore I have that Q, considering P and Q as meta variables. So, line 4, I have L and not the case that M. How do I have that? From lines 3, 1, conditional elimination. I have that conditional elimination again because I have the antecedent. And if I have the antecedent of the conditional, I can grab its consequent. How did I get this antecedent? It's the opposite of my target sentence. Now, if I have this sentence, if I have this consequent here, it's an and. What can I do with an and? I can take it and break it apart, which is awesome. Now, my goal here is to try and get a contradiction. Why do I want a contradiction? I want to discharge the opposite of this assumption, because the opposite of that assumption is look, there it is, my target sentence. So, are there any good contradictions around? Right here, N and not N? You're right. So, if I break this apart, I get not N from 4 conjunction elimination. Then I could just repeat it over here, and that's just 2 repeat. And that's just kind of good housekeeping. I want to make it really clear that the contradiction is there. And then line 7, I will cease this vertical line, come back to the main line, and say, actually, you know what? I and M. Why? Because on lines 3 to 6, I have a contradiction. So I'm going to use negation elimination. Because assuming the opposite of my target sentence led to a contradiction. So if all else goes wrong, you can always just assume the opposite, derive a contradiction. All right, so there's lots of other good examples. I did what? 1 and 3 and 7. You really should stop and work on some of the other ones. All right, so pause the video and work on some. Here are some exercises from the textbook. I wrote page 242, but I think the pagination might have changed, so this is probably section 8.2 or 8.3. But I wrote them down anyway, so it's all great. So these all require use of conditional derivation and indirect proof. By indirect proof, I just mean assuming the opposite and deriving a contradiction. So why don't we should just do more because there's so many more to do. In fact, I'm going to pause the video, erase the board, and it's going to be like a magic trick. Poof. Okay. So I've chosen some of these exercises to do. The first one is pretty easy. Have you done it? Pause the video, do it. Okay, so not A, and we're going to derive A. That's actually pretty easy. What we should do is simply assume the opposite of A, not A, and show that, reiterate the premise 1, and boom, we have a contradiction. Very easy. How about number 2? Let's do that one. So if A, then B, and not B, therefore not A. So I've said all of these are going to require conditional proofs. That's right. So we have not A as our target sentence, so why don't I just assume the opposite? Right? I don't have a lot of moves available to me here, of course, given the rules that we have in our back pocket. Right? You could always use disjunction introduction, but what am I going to do with like either not B or Z or something like that? Either not B or A. There's not really a lot you can do. So negation introduction will be pretty good here because what we have is we're looking for not A, so if I just assume A, maybe I'll get something useful. What would I get if I assumed A? Well, I'd probably get B. This is an assumption. Y for negation introduction. How do I get B? I have A, and on a scope line to the left of it, I have if A then B. That's pretty useful. So I have that via 3-1 conditional elimination. But of course, I'm already committed to not B on line 2. So that's line 2 reiteration. That's a premise. So what I have here is a contradiction, B and not B. So if I assume A, I got a contradiction. So if I have a contradiction, I can discharge not A because assuming A leads me to a contradiction. So that is negation introduction. Contradictions right there. Could I have done something else? Sure. I probably could have, if I had done like a conditional introduction, I could have said, if I get A, then I can prove not B. That would follow. But for this derivation, I've shown that from the premises, not A is entailed. In other words, this is a valid argument from these premises to that conclusion. All right. How about, let's see, what else can we do? All right, I'm going to pause the video and erase the board. All right. How about we do number 5? That's actually the hardest one. I put it up on the board right over here. So let's look at the premises and let's look at the target sentence, the sentence we're supposed to derive. We need to show that either G or H, the sentence G or H, follows from the premises. And if it follows from the premises, that means the premise, these premises here form a valid argument for the conclusion. But this is a bit of a tricky one. First thing we should always look at is the target sentence. What is the main logical operator here? It's a disjunction. How do we create a disjunction? We don't have a lot of options. Disjunction introduction is one way, but in order to introduce a disjunction, we have to have one of the sides of the disjuncts. If I can get G, then I can go or H. If I had H, I can go or G. What are the chances that I'll be able to get G or H? Well, now let's look at the premises. G and H are the antecedents of conditionals. We'd have to be able to get F or not F, but that doesn't look very likely. Our conditional elimination rules aren't going to be of much help here. So how can we create the conditional otherwise? The only other option seems to be to assume the opposite and hope we get a contradiction somehow. So let's do that. So I don't really have a game plan yet. I just know that hopefully if I assume the opposite, I'll be able to get a contradiction. Now, this requires some thought. Now, I know this is a valid derivation. So maybe if I just look at the structure of the premises, I'll be able to understand why G or H is entailed. Well, let's see. If not F, then G. However, if F, then H. Therefore, either G or H. That kind of makes sense. F is either true or false. And what the premises are saying is like, look, if F is true, then H. If F is false, then G. So either G or H. One of these has to be true given the premises. All right, I can kind of see where that works. But unfortunately for us, it's not very helpful. It's not very helpful for us because how on earth are we going to get G or H from that, from these conditionals? I understand that the conditionals say it's one or the other. If it's one, it's G. If it's the other, H. Therefore, given the premises, G or H has to be true. But how do I build that? Well, if I negate the G or H, what I'm saying is, well, neither G nor H are true. G isn't true and H isn't true. But if G isn't true and H isn't true, then F has to be false and not F has to be false. So our contradiction will probably be somewhere lying amongst the F's, because negating my conclusion means that F has to have contradictory truth values. All right, so now my strategy has evolved a little bit. I've assumed the opposite. That's good. And by assuming the opposites, I know I need to derive a contradiction. Also good. But what is going to be my contradiction? Well, the internal structure of the premises suggests that F would be a good target. But how am I going to get a contradiction out of these conditionals? Well, here we have to start thinking a little bit. Think about the rules we have. What kind of contradictions I can make. So, I know that if I have the antecedents of these things, I can get their consequence. I don't have the antecedents, but maybe I can assume them. So 3 is an assumption, and I'm trying to do negation elimination to get at my target sentence. That's good. But now I've kind of twisted myself up into a problem where I don't really have many ways of dealing with negated disjunctions. I know in my head that a negated disjunction is equivalent to a conjunction where not G and not H, but we don't actually have a rule allowing us to extract those yet. Later on, I'm going to introduce some rules that'll make things easier, but for now, we're playing on hard mode, and we don't have a way of turning a negated disjunction into a AND statement. However, I do have a negated disjunction here, and if I get G, I might be able to use disjunction introduction and get a contradiction somehow. This seems promising, actually. Hold on. So, even if you don't understand what I'm doing here, just make assumptions and see what happens, right? So, okay, suppose I assume not F. And why am I doing it? Maybe another negation elimination. This is another sub-assumption. Now, what does not F give me? Even if I'm not sure what the heck I'm doing, I know not F could give me at least G. Is this useful? We have an assumption baked inside a sub-assumption. But I do have a rule called disjunction introduction. Hold on a minute. If not F gives me G, but sentence 3 says neither G nor H. So if neither G nor H is true, G can't be true. And if G can't be true, then not F can't be true. We found the seeds of the contradiction we're after. But how do I show it? Well, if I use disjunction introduction, I can get either G or H. How did I get G? I got it from 4, 5 conditional elimination. This is line 6 over here. And I get G from G or H from 5 disjunction introduction. All these moves are legit. Now I have G or H and not the case of G or H. That's a contradiction. I'm running out of room on the board, so I'm actually going to forego the reiteration rule, right? But we have this, not the case of G or H and G or H. That's a contradiction. It basically is equivalent to P and not P. Now remember, the contradictions don't need to be atomic sentences. The way I give in the rules, it's about the logical form. These things represent metavariables. P and not P could be any complex sentence. So we have a nice contradiction here and here. So if I have a contradiction here and here, I know that not F can't be the case. So I can discharge over on this line, line 7. I'm going to close this vertical line. I'm going to say, well, hold on, F can't be true. Not F can't be true. F must be the case. Of course, if F is the case, I have H. So let me just justify here. So I have 4 through 6. And that was, of course, a negation elimination. Right? I assumed not F, and I got a contradiction. So I got F. F gives me H via line 7 and 2. And that's a conditional elimination. But I'm still operating under the scope line of my first assumption here. Right? My assuming the target sentence is false. But if I have H, guess what else I have? I can just run this disjunction elimination again and get, of course, G or H. So we ended up with something actually pretty useful. Here's another contradiction, G or H. So therefore, right, how did I get this? I got this from 8 disjunction introduction. I have a contradiction here. If I assume this, I actually can derive the opposite. So line 10, I'm going to have to write it. And we're still operating under the scope line of this one. I ran out of room, so let me just keep going dot, dot, dot. You can't see over here, can you? Let me just keep going. Make a line separating dot, dot, dot. Line 10. What does line 10 need to say? You could say G or H. And why does it say it? It says it because of all of lines 3 through 9, conditional, negation, elimination. So that was a very complicated proof, right? But the basic strategy, I knew there was going to be a contradiction somewhere, and I knew it to focus on the F's, and then eventually I'd be able to get it down there. So I assumed the opposite of my target sentence. I know that the opposite of my target sentence entails that both G and H must be false, both of them. However, if both these sentences are false, it implies that the T's, the F's over here have to have contradictory truth values. So if I assume F, not F, I can get G, either G or H, contradiction. So not F can't be the case given this assumption. So F must be the case. But if F is the case, I generate another contradiction. So this one now has to go, and we're able to discharge on line 10 our target sentence. That's a pretty cool proof. Again, just rewind, run it through a couple times. This is not an obvious derivation, but it kind of gives you a sense of the kind of strategies and thinking that you're going to need to have in order to prove these more complicated derivations. All right. So, now we know that two sentences of sentential logic are logically equivalent if you can derive each of them from the other, right? I can derive not P or Q from if P then Q. That's actually pretty easy. Vice versa. I mean, it's the case that the biconditional here is a tautology. If not P or Q, if and only if P then Q. Now, earlier I talked about substitution instances, and then I just kind of ignored it for a half hour. But what I want to say here is that once you've proven that two sentences are equivalent, you could introduce a new derived rule, such that an instance of one sentence can be replaced by its proven logical equivalent. Now, the introduction and elimination rules that we've just talked about are actually complete. They allow for the derivation of all and only the validly entailed sentences from premises. And the reason we worked without any other substitution rules is because it would actually make it a bit too easy. But now we're going to add some new rules, some substitution rules that are going to make our job even easier. That's what we're going to be doing in the next video.